Let's take a look at example 2. So example 2 has to do with this very important factor called the z-value, which is dealing with how many standard deviations a particular value is from the mean. So here's our formula. You take your random variable, you subtract the mean, and then you divide by the standard deviation. So our formula, I'm going to go ahead and write it again. The z-value, and because some people say my z's look like 2's, I'll put a line through it, is going to be the random variable minus the mean divided by the standard deviation. So in this particular problem, we would have 36 minus the mean of 40 divided by our standard deviation of 6. So 36 minus 4 is negative 4. Divide that by 6. I'm getting negative 2/3. Or approximately negative 0.67. Be 6 repeating. So what does that mean? That means 36 is 2/3 of a standard deviation to the left of the mean. That's what it means. So if you had the mean here, the 36 value would be 2/3 of a standard deviation to the left. So just to kind of give you a better idea, here's your mean of 40, a standard deviation of 6. Let's remove these values here. The value 36 would occur almost not even one whole standard deviation to the left. The value 36 would not even be one standard deviation to the left. So one standard deviation would be 6 over, which would get us to 34. If these are counting by 2's, this would be 34. 36 is within one standard deviation, but left of the mean. That's the idea. So on this one, let's do this again. Find x. So we know, here's the formula again, z is equal to x minus mean, the random variable minus the mean divided by our standard deviation. So in this particular problem, they gave us the z value. So z equals 1.5 equals x minus the mean of 1.3 over our standard deviation of 0.6. So we need to do a little algebra to solve this. So I'm trying to isolate the variable x, so I'm going to do the opposite operations of what I see. What's the opposite of division? It would be multiplication. So I'll multiply each side by 0.6. So 0.6 times 1.5, I believe will be 9, or 0.9. Let's see, 0.6 times 1.5. is 0.9, that's correct. So I have 0.9 equals x minus 1.3. When I add my standard deviation, I will have my random variable isolated and won't be so random anymore. When I add these together, 2.2 is equal to x. And that would be my value. So this is saying if the mean was 1.3 and we had a standard deviation of 0.6, this value would be to the right of it, so it would be greater. And that's why we got 2.2. It's to the right, it's greater than 1.3. Your turn. Find z, given a random variable of 52, a mean of 58, and a standard deviation of 4.